Okay, so this is our B point and this is O and ON. So now the maximum we consider, already we have considered that we consider small element. Okay, small element of the break lining AC is subtending an angle del theta. Okay, and this is a small element we have the lining, the ferromagnetes. And now OA is max an angle, OA is max angle with OA is the theta. Okay, it's clear with OA. Okay, now I have written here once again the maximum means the pressure is maximum pressure in any point is directly proportional to the radial distance. Okay, as the distance is increasing the pressure may be the increasing. So using these are the radial distance OB1, the radial distance O1B equal to using the sine theta, because this is our theta and this is the base, this is the perpendicular, this is the hypo. So OAB equal to nothing but OA and sine theta. So this basically is depend on the sine theta's proportional area. So similarly the normal pressure of at any point, suppose that is the A point, any other point is proportional to the radial distance sine theta. So similarly here we write here the OA. So pressure at any point, so normal pressure at any point is nothing but this is the Pn I have written here. This is the Pn is normal pressure. The normal pressure, okay, I have written the maximum pressure. So this Pn is pressure at any point is nothing but the Pa sine theta. So this is the variations, and this is the P1 is the maximum pressure, and this is the normal pressure at any point. So this is the variation, it depends on the thetas. Okay, the pressure may be not constant but depend on the theta here. So what is this is the pressure, what is the normal, then the normal force. Okay, you must be remember the normal force acting on the element. So what is the normal pressure on the element? So because what is the normal force? Okay, this normal force is this directions. This pressure is normal force, because just you know that it is a calculated using the friction force. The friction force is nothing but the normal reaction, means friction force is a mu and Rn. So this is a normal reaction, this is a coefficient, and because of फ्लूइड मटेरियल is a more coefficient friction. तो किसी भी मटेरियल के लिए फ्रिक्शन कोफिशिएंट जो होना चाहिए, जो मटेरियल यूज़ करते हैं लाइनिंग मटेरियल के लिए, जो लाइनिंग मटेरियल हो गया, इसे तो कोफिशिएंट ऑफ इट शुड बी वेरी हाई. So therefore we have must calculate the normal reactions on the drum using this lining materials. Yes, sometimes it's the force, yeah, by these shoes. So therefore the normal force acting on the element is it is the meaning of that means nothing but the pressure into the area. The pressure into the area, it is our normal force, because we know that the pressure is nothing but the force by area. The force can be calculated by the multiply just the pressure to area. So therefore the normal pressure, if you write that, that means on the small element. The small element, just we take the small element normal reactions on this AC as assume the small element of lining, and therefore this is a normal reaction, and just the normal is not nothing but the normal pressure. Okay, the normal pressure into is the area of a small element. Okay, what is the normal pressure? I have calculated this will depend on the maximum pressure with the angle. So suppose that the P1 is the maximum pressure of the lining materials, with term P1 is the sine theta. Okay, and now is the area of this small element. What can calculate the area? Here is looked at. What is the area of this element? This is the area element. So simply this is the area should be, how can you calculate? Therefore this is the B, suppose this ये एक small element area हो गया, this is AC, okay, this is A and C, this is B, and what is the value of this one? तो this is A to C, तो this is the B into this, ये मान लेते हैं एक तरह का मेरा रेक्टेंगुलर शेप हो गया, तो B दिया हुआ विड्थ ऑफ दिस लाइनिंग एंड टू दिस, एंड दिस इज व्हाट, दिस इज AC, दिस इंटू दिस AC, तो यूजिंग R इंटू डेल थीटा, जैसे कि हम लोग इस तरह का पढ़ते थे सेक्टर वाला में, तो ये थीटा हो गया, ये R इंटू L, जस्ट वी कैलकुलेट द L, ओके। तो सिमिलरली दिस इज द AC into R and theta, so therefore this is nothing but what is the R and del theta, and this is in B, so B into AC, so just so we have right here, so B is the width of the shoe into R into del theta, okay, just you solve it, and now this is our normal reactions. Now calculate the breaking frictions on element. Element means AC, okay. So therefore the force is the friction force, and you know that what the direction of the friction force, anybody, what is the direction of the friction force, this, what is the direction of this force, because this is a friction force, so suppose that when it's rotating of this direction, okay, so then the force on this drum will be, because it's the opposite direction, but due to have this direction, the friction force on this direction of this element here, so this is our nothing but the del F, the friction force here, okay. If this is direction of the friction force, just normal perpendicular, just perpendicular to the normal force, so del F is here, so multiply with the nothing friction force, and so the friction force here, the coefficient of friction of the materials, and this is a small normal reactions, so just right here, then it is a braking frictions, then what is the braking torque, due to frictions about O, okay, about O means this is the friction force, this is about this moment, okay, this is a friction for this into this R, so we write here, del TB, del F into R, so we write U P1 sine theta B R sine, sorry, del theta into R, we can write here mu P1 B R square sine theta and del theta, so total braking torque, the TB total torque, mu is the coefficient, is the maximum pressure of intensity is given the material, and how much pressure can be resist, this is a constant width, and this radius is a constant, and we taking the theta 1 to theta 1 because it is theta, so sine theta into del theta, so just to integrate we find the result, so TB here mu P1 B and I squared just cos square theta and theta 1 and theta 2, so again we write TB mu P B R square, okay, and cos theta 1 minus cos theta 2, it is our general equations to calculate the maximum torque. So basically if questions comes about write the short notes on the internal expanding brake. So you must write the some fundamental concept about the internal expanding brake, and then go to the some derivation about this point. And there is no chance to come the numericals on the internal expanding brake, because in your GOT syllabus is written that no ask questions from internal expanding brake. Yes, question may be asked from the differential band and shoe brake only, as it in the GOT syllabus. So don't to try to solve this numerical, and this question, this numerical is if you try and solve internet expanding brake, it may be the beneficial for your future, but in the sense of the SSC and GATE and other competitive exam, almost zero. There are no ask questions from the internet expanding brake on the numerical base. So it is just to write this how to work and what is the principle of the internal expanding brake. Okay. Now this is our brake system complete almost, and now come to the next topic is a dynamometer, and what is the meaning and what is the use and application of the dynamometer in the domestic life and as well as the industrial life, and is as well as sometimes called use in lab. And now before going to the discussion on the dynamometer, some objective I'm asking about you ki some sorry. So some objective like the first question I am asking, that is what is the brake, you can give your answer in your mind. So what is the brake commonly used in the railway train, जो गाड़ी जो रेल चलता हम लोग का उसका अगर तुम ऑब्जर्व करोगे, अभी तो आना जाना बंद है, जब तुम लोग ट्रेन का जब चक्का को देखोगे कि उसमें कौन सा ब्रेक यूज़ होता होगा, तो डिपेंड्स इन द इट्स यूज द शू ब्रेक. ओके, शू ब्रेक जो ट्रेन के चक्के पर होता है, उसके चक्का का व्हील जो होता है उसके ऊपर शू ब्रेक लगा रहता है. तो बेसिकली हम इसमें यूज़ करते हैं शू ब्रेक. जब रेलवे जब हैवी एनर्जी रहता है तो उसको रोटेट करने के लिए हम लोग यूज़ करते हैं. सेकंड क्वेश्चन है कि मोटर कार, व्हीकल्स, मारुति, अल्टो, ये सब में कौन सा ब्रेक यूज़ करते हैं. जवाब होगा इसका इंटरनल एक्सपेंडिंग ब्रेक यूज़ होता है. क्वेश्चन नंबर थर्ड कि किस तरह का मटेरियल यूज़ करते हैं हम लोग हैं. कोएफिशिएंट ऑफ फ्रिक्शन कैसा होना चाहिए. यस, ऑब्वियस आंसर राइट, इज शुड बी द हाई. द कोएफिशिएंट ऑफ फ्रिक्शन मटेरियल का वैल्यू हाई होना चाहिए. जितना ज़्यादा हाई होगा उतना ज़्यादा फ्रिक्शन टॉर्क लगेगा, क्योंकि बिकॉज हियर द मैक्सिमम टॉर्क इज proportional to the coefficient, and this equation is not is internal expanding in all the others like the differential, sample and simple and shoe brake. All the torquing brake is depend on the coefficient of friction. So if the coefficient of friction is more, then that means this material should be used as the brake materials and sometimes brake lining. क्वेश्चन नंबर 2 है कि व्हेन द फ्रिक्शन फोर्स हेल्प्स टू अप्लाई द ब्रेक. जैसे मान लो कोई फ्रिक्शन, कोई भी ब्रेक ऐसा जिसमें आपको एक्सटर्नल फोर्स अप्लाई करना पड़ रहा, तो क्या ये सेल्फ लॉकिंग ब्रेक हुआ. नहीं, सेल्फ लॉकिंग होने के लिए हमें एक्सटर्नल ब्रेक की ज़रूरत नहीं होता है. ठीक है ना, मतलब कि हमें ब्रेक के यूज़ हमको बाहरी कोई फोर्स की ज़रूरत अगर पड़ता है तो समझ जाना तब वो हमारा सेल्फ एनर्जाइजिंग ब्रेक हुआ. ओके. और अगर हमें फ्रिक्शन फोर्स की ज़रूरत नहीं है, मतलब हमें कोई एक्सटर्नल फोर्स की ज़रूरत नहीं पड़ा, हमको वो अपने आप ले लिया, तो उसको बोलते हैं सेल्फ लॉकिंग. अगर हमें एक्सटर्नल फोर्स की ज़रूरत पड़ रहा है, ठीक है, तो वो हमारा सेल्फ एनर्जाइजिंग ब्रेक कहलाता है. तो ये हमारा एक क्वेश्चन हो गया जो तुम्हें अपना याद रखना है. ओके, तो ये हमारा कुछ ऑब्जेक्टिव था, जो ऐसे ऑब्जेक्टिव बहुत से क्वेश्चन ट्राई कर सकते हो. और नेक्स्ट टॉपिक हम जो है वो डिस्कस करेंगे द डायनामोमीटर्स. ओके, डायनामोमीटर हमारा कैसा होता है, लैब होता है तो वहाँ पर तुम डायनामोमीटर पे दिखा देते हैं कि कैसे डायनामोमीटर काम करता है. ओके, तो नेक्स्ट वीडियो हम इस पर अपलोड करेंगे कि डायनामोमीटर. तो आज का क्लास के लिए इतना ही मेरा ये रहेगा. नेक्स्ट डे हम सैटरडे को हम इस पर डायनामोमीटर पे हम इस पर डिस्कस करेंगे. ओके.